Good evening, millennials. Today we'll look at another lead code problem often asked in the intermediate rounds of FAANG interview companies such as Amazon. So this is the 735th problem in the lead code website called Asteroid Collision. So I will read through the question and then discuss the most efficient approach and code on the fly to write the most shortest code possible as in an interview. So we are given an array asteroids of integer representing asteroids in a row. For each asteroid, the absolute value represents its size and the sign represents its direction. Positive meaning right, negative meaning left. Each asteroid moves at the same speed. Okay, find out the state of the asteroids after all collisions. If two asteroids meet, the smaller one would explode. If both are of the same size, both will explode. Two asteroids moving in the same direction would never meet. Okay, so let's look at the examples to understand the question better. So when it's 5, 10 and minus 5, 5 and 10 are moving towards the right and minus 5 is moving towards the left. In this case, 10 and minus 5 will collide and the bigger one will prevail, which is 10. So the final answer we will get as 5 and 10. When the examples are 8 and minus 8, 8 is moving towards the right and minus 8 is moving towards the left. So in that collision, both will go as both are of the same size and you will get an empty array as the answer. And let's look at the third example. When it's 10, 2 and minus 5. So initially 2 and minus 5 will collide and then minus 5 will prevail. Then in the remaining 10 and minus 5, 10 would prevail as 10 is greater than 5. So let's look at the constraints. So the asteroid's length is between 2 and 10 power 4. So the important takeaway from this point is to note that you can't write an n square algorithm, but you only need to write an order of n algorithm. And so here if you look at it, each of the asteroid size is between minus 1000 and 1000. And the asteroid's value is never 0. So if you want, you can have a peek at the hint. So it would be discussed in our discussion. So as you can see, when we are building the final array, you can see it can be built by passing the asteroids from left to right, and the final output array can be processed by the incoming element on one side. So this array requires only the current element and the entry from one side. So as you all know, stack is the best application for this question because stack is based on LIFO, last in first out. If you need more information on stack, you can look at our other videos. So let's look at the examples and try to figure out our algorithm. So if both are moving in the same direction, that is, if both are positive, we can just add it to the stack. Or if the stack is empty, we can just add the element to the stack. And assume the stack's last is negative and the incoming element is positive, then also we can just add it to the stack, as this element, the stack's top element, would have been moving towards the left and the new incoming element would move towards the right. Also, if the top element is negative and the incoming element is negative, there would be no collision as both would be moving towards the left. So the only case of collision is when the top element is positive and the incoming element is negative. So in that case, we need to process the negative element till it can collide with the all possible outcomes. So when we get a minus 5, we just process the stack such that we can remove the elements till the incoming one is greater. And we don't need to add this element in this case. So the final answer would be 10. But in other cases where the incoming element is greater, we just keep on colliding it. And in case the incoming elements are equal, we just remove from the stack and don't add this as well. Else, we just add it to the stack. So let's try to write the code for this. So since the return type is vector, I just maintain a vector int stack and I return the stack at the end of the function call. So now I iterate through the asteroids for auto asteroid colon asteroids if the stack is empty, which means it's either the first iteration or the stack, all the asteroids till that point have collided and it has resulted in an empty array, or the stack stop or the stack's back. Since we are using a vector, we have to use the back function, is negative, which means it doesn't depend on the incoming element, so we are just going to push the incoming element. Or if the incoming element, which is asteroid, is greater than 0, we just push it to the stack. So this is the case we discussed. Else, when the incoming element is negative, we need to remove all the asteroids in its direction till its absolute value is greater than the stack stop. So till while not of stack dot empty and if the stack stop is positive, so because if it's negative we don't remove it, right? So the top should be positive, back. Since we are using a vector, I'm just writing it back, but it's based on a stack LIFO technique. And the absolute value of the asteroid which is incoming is greater than the stack's back. Sorry, it should be stack. So till it's greater than the stack's back, what do? I just pop from the stack. So stack dot pop underscore back. And if the stack is empty or the stack's back, so we have to look at the case where the both the elements, so the incoming element is lesser than the existing element. So always inside this F condition the asteroid would be negative. So when it's negative and if the stack is empty or the stack's back is also negative, which means that both are moving in the same direction, that time both are moving towards the left, here we just push it to the stack. Else, this is the case where the both elements are equal. Else if the stack is not empty and stack dot back equal to the absolute value of the asteroid, then we just pop from the stack and we don't add anything back to the stack. So after all this processing, we would get the final array, the final stack, and I just return it, and it's a vector int. So I'm just try running the code. So when asteroid is positive or the back is negative or the stack is empty, I just push it. Else, while the stack is not empty and the stack's back is positive and the incoming is a greater negative, then I just pop on the final one. Else, if the stack is empty or the stack's back is negative, then I just push back the asteroid. Else, if the stack is not empty and the stack's back, so it's a function call, is equal to the absolute value, then we remove both of them. So I just remove the top of the stack and I don't add anything to the stack. So just let me run this code. So it passes for this. So let's run it all. I just tried to run it a few times. Yeah, as you can see, it has been accepted and its memory usage is better than 99% of the solutions. So if you can write a better, shorter code than this, please leave it down in the comments below. as we are open to constructive feedback and we always want to make our code better. Thank you, and please like, comment, and subscribe if you can help us. Thank you.